Hello guys, so in this video we are going to learn properties of trigonometric function sine theta, cosine theta, which are the foundational function, and then from the other trigonometric function including tan theta, cosecant theta, secant theta and tangent theta. For that we're gonna use our right angle triangle and Pythagoras theorem to start with. So let's start. So we're gonna start with the Pythagoras theorem. I suppose the spellings are correct. So in Pythagoras theorem here we have taken P as a perpendicular, which is along the y-axis. Here the B is base, which is along the x-axis, and H is the hypotenuse. Okay. So in Pythagoras theorem the sum of perpendicular square plus base square is equal to hypotenuse square, right? So let me call this as left hand side and this as right hand side. So what I'm gonna do is, to make this equation more simplify, I'm gonna do a small mathematical manipulation. I'm gonna divide the entire equation, both the left and the right hand side, by h square. Okay, so think of it like I have an equation. Let me give you an example. If I have an equation which is like 3 square plus 4 square is equal to 5 square, which is same as writing 25. Okay, this fulfills the hypotenuse. If I divide the entire equation by 25 on both sides, this will become 3 square by 4 square by 5 square plus 4 square by 5 square. This is equal to 5 square over 5 square, which is 1. Okay, I want to achieve this one here. I want to achieve this one here. So this one I want to achieve here, which can only be done if I divide the entire equation by h square. So that's what I'm gonna do here. Let me erase this. So this will be p square upon h square plus b square upon h square, which is equal to h square by h square. So remember, any number divided by any number other than 0 will always be 1. Okay. Now the great thing about this equation is the sum of two positive number, p square by h square and b square upon h square, is 1. What it means is, first of all, why these numbers are positive? First of all, because these are square, and second, since the sum of two numbers is 1 and these numbers are positive, this is only possible when these two numbers lie between 0 and 1. For now, let's forget it. So if we convert this into a trigonometric equation, so let me use a black pen. So this perpendicular by hypotenuse, if I call this as p by h, if I call it as sine theta, and base over h, if I call it as cos theta, then simply it will become sine theta square plus cos theta square is equal to 1. If you see this here, I'm getting p square by h square is sine square theta, b by h square is cos square theta is 1. So as you can see, I have derived sine square plus cos square theta is 1, which is an identity, which is how we are getting using a right angle triangle. And always remember this, whenever you write sine theta, right? Now sine theta will always be perpendicular by hypotenuse. So perpendicular is the side which is opposite to hypotenuse, and cos theta is base upon hypotenuse. So if you want to learn cosine theta, cosine or cosine theta, you can simply write it as that complement of sine. Okay. So remember, sine theta will always be perpendicular by hypotenuse, and cos theta will be base by hypotenuse. Now the thing the thing to remember is, let me insert this thing in a box. And I box it. Yeah. See, now at any given time in a triangle, hypotenuse will always be greater than one of the sides. So hypotenuse will always be greater than P and base. If I give you one example, 3 square plus 4 square is equal to 5 square. Here hypotenuse is 5, base is you can say, let's suppose base can be anything. So let's suppose base is 3 and perpendicular is 4. So here sine theta will be, remember sine theta is P by H, okay, which is 4 over 5, and cos theta is base over H, where base is 3 over 5. So you can always see that either of the sine theta or cos theta will always be less than 1, but they will be greater than 0. So that's the property of sine and cosine theta. They will always be less than 1 but greater than 0 here in the triangle, because as long as P and base are less than hypotenuse, which takes us back to the original equation. Sine square plus cos square theta is 1. The sum of two numbers, sum of square of two numbers which is equal to 1 is only possible when these numbers, individual numbers sine and cosine theta, are less than 1. Okay. Now let's go back to trigonometry function. Now that we know about sine theta and cosine theta, let's go to other trigonometry function. So we are done with sine and cosine theta for now. Let's go to tan theta. So if you divide A over B, we get a new trigonometric function which is called the tan theta. Okay. Now let me use another pen. Now if you take the reverse of sine theta, here if you take reverse of sine theta, this will be 1 over sine theta. Okay, this will be called cosecant theta. Similarly, if you take reverse of cosine theta, this will be cosecant theta, which is 1 over cos theta. And if you take the reverse of tan theta, this will be cotangent theta, which is 1 over tan theta. So if I use another pen, cosecant theta is nothing but 1 over A. This is 1 over B, and this is 1 over C. Here I have written A, B, and C. So let me show. If you just remember sine and cosine theta, just sine is a starting point, then you get cosine theta, if you divide sine by cosine, that means sine is in the numerator and cosine is in the denominator, like this. Sine theta by cosine theta, it is tan theta. And again, 1 over sine theta is cosecant theta, 1 over cosine theta is secant theta. That's my bad. This will be secant theta. This will be secant theta. And 1 over tan theta is cot theta. So remember, this is opposite. The reverse of sine is cosine, cosecant. The reverse of cosecant is secant. And reverse of tangent is cotangent. Now, if we go to previous example, here, if I were to copy this and erase with an eraser, okay, let's erase this. Yeah, so I know that in the previous example, sine theta is perpendicular 4 over 5, cosine theta is base over hypotenuse 3 over 5, tan theta will be sine theta over cos theta, which is nothing but perpendicular over base, which is 4 over 3. Okay. Now, if I want to find cosecant theta, let me use another pen. Now, cosecant theta, this is inverse of sine theta. This will be 5 over 4. Secant theta, this will be reverse of cosine theta, which will be 5 over 3. And cotangent theta, this will be reverse of tan theta, right, which will be 3 over 4. Now, if you note in this example, this is just an additional point. As I told you, sine and cosine will always be less than 1. Here, cosecant is greater than 1. If you do 5 by 4, it is greater than 1. And secant is also greater than 1. In our upcoming classes, we will understand why cosecant and secant take values greater than 1 and why sine and cosine take values less than 1. Now remember this identity that we had come across, sine square theta plus cosine square theta is equal to 1. Now we're going to practice here and derive more identities out of it. Let's see how. So, let me erase this. Now I know sine square theta plus cos square theta is equal to 1. Okay. Remember, this is LHS and this is RHS. Let me write LHS, RHS. Now, if I divide both the sides by, let's suppose, cos square theta, okay, so this will become sine square theta by cos square theta. Just for the fun of it, I'm doing, okay, cos square theta divided by cos square theta is equal to 1 over cos square theta. Okay, divide both sides. Let me use a different color. So now remember, sine by cosine square theta is tan theta, right? So we are going to write tan square theta. Cosine square theta by cosine square theta will be 1 plus 1 is equal to 1 over cosine square theta is secant theta. Okay, so this will become secant square theta. So you see what we arrived is 1 plus tan square theta is equal to secant square theta. All this from this equation. Can you see? Let's box it. Students generally remember this, which would obviously come out of practice, but this identity, I call this identity, can be derived from the original equation sine square theta plus cosine square theta equal to 1. Let me box it. Here's the box, here's the box, here's the box. Come on. Yeah. Here we box it. Here it is. So now let's go to another identity. Let's copy this. So yeah, I use a different pen. Remember again, sine square theta plus cosine square theta is equal to 1, right? This is LHS and this is RHS. Now if I divide both sides by sine theta, okay, just for the fun of it, let's do that. So this will become, let's write with red only, sine square theta divided by sine square theta plus cosine square theta over cosine square theta is equal to, sorry, I'm dividing by sine square theta, right? Cosine square theta over sine square theta is equal to 1 over sine square theta. You know, I can take the liberation of dividing both the sine by sine square theta because ultimately they can be factorized, okay? So sine square theta by sine square theta is 1 plus cosine by sine. Now cosine by sine is nothing but inverse of tan. You know, tan was sine by cos, so this will be cos by sine, which is cotangent theta. And 1 over sine square is cosecant square theta. If you go at D, it's cosecant. So you see, we derived another identity, which is 1, let me write with a darker shade, 1 plus cot square theta is equal to cosecant square theta. Oh, this is much darker. So you see, I derived another identity from here. I mean, you can derive endless identities. This is 3, this is 2, and this is the mother of all identities, 1. So the question is, if you know the relation between sine and cosine, if you remember sine square theta plus cosine square theta is 1, if you remember the properties of right angle triangle, if you know the Pythagoras theorem, if you know that sine theta is nothing but perpendicular by hypotenuse and cosine theta is base by hypotenuse, then you can do wonders with trigonometry. And you don't even need to learn this, just this will come with practice. And you can derive all other relations, sine, cosine, tangent theta, which is sine divided by cosine theta, then cosecant theta, which is the inverse of sine theta, secant theta, which is the inverse of cos theta, and cotangent theta, which is inverse of tan theta. You can derive anything and learn this. That's it for this class. If you have any doubts or queries, and if you want to get in personal touch, you can check the description box, and the details are there if you want to message me. Well, thank you for your time. We will discover more about trigonometry in the next class. Bye. Have a great day. Thank you.